Hey everybody, ready for another deep dive. Today we're tackling something that sounds super basic, but it's actually incredibly powerful.
Yeah.
We're going to be talking about really understanding a problem, like deeply understanding it
Mm.
before you even think about writing any code.
I think that's something that people try to skip over quite often.
Yeah, right. It's like you just want to jump in and start like fixing things, you know?
Right.
Get your hands dirty.
Yeah, get into the code.
Exactly. But today we're going to be using some insights from the Algo Academy blog
Okay, cool.
to talk about why that might not be the best approach.
Well, it's really interesting because not only is it about avoiding coding mistakes, but it's actually about finding the most efficient and elegant solution possible.
Okay, so walk me through this.
Okay.
Why is this understanding first mindset such a game changer?
Well, think about it this way.
Okay.
You wouldn't build a house without blueprints, would you?
Definitely not. I've seen way too many of those home renovation shows.
Right. It's just a recipe for disaster.
Exactly.
Yeah. And it's the same with code.
Okay.
When you really understand the problem, you're basically creating those blueprints for your code before you even start.
So it's like more than just like carefully reading the problem, you know?
Absolutely.
More.
Internalizing it,
Really?
dissecting it, and seeing it from multiple angles.
Okay.
Asking yourself, what's the core challenge here? What are the constraints? What are the potential pitfalls? That deeper understanding allows you to craft a solution that's not just functional, but also elegant and efficient.
Okay, I can see how that would definitely save you some headaches down the road.
Right.
So let's get specific.
Right.
What are some of the tangible benefits of like really understanding a problem before you actually dive into the code?
Well, first and foremost, it leads to much more efficient solutions.
Okay.
When you understand the problem really well, you're going to write cleaner code that just gets the job done with less wasted effort.
So it's like working smarter, not harder.
Exactly.
I like that.
Yeah. Yeah. It's like the difference between hacking your way through a jungle and following a well-marked path.
Okay.
The clear path might take a bit more planning up front,
Mm.
but you'll arrive at your destination much faster and with fewer scrapes and bruises.
Okay.
Right.
And I bet it helps avoid those dreaded edge cases too.
Yes.
You know? It's like those little details that can really trip you up if you're not careful.
Yeah, absolutely. When you deeply understand the problem, you're more likely to anticipate those tricky scenarios in advance,
Okay.
saving you from having to go back and rewrite code over and over again.
It's like those terms and conditions that we all skip over.
Yeah.
You know, sometimes those tiny details actually really do matter. And encoding those overlooked details, they can lead to major bugs.
Exactly. And speaking of bugs,
Yeah.
another huge benefit is that it makes debugging way easier.
Okay.
When you understand the structure and logic of your code, spotting and fixing errors becomes much less of a headache.
Okay, that's huge. I can't tell you how many times I've been lost in a sea of code.
I'm sure.
You know, just trying to track down a bug. It's like trying to find a typo in a giant document.
Yeah.
If you understand the structure of the document, it's way easier to find that error.
For sure.
And this whole process of breaking down problems and analyzing problems, I feel like that doesn't just make you a better coder.
No.
It makes you a better,
Problem solver.
yeah, problem solver overall.
Yeah.
Okay, so we've established the why, you know? Understanding the problem is key
Right.
to better solutions.
Yes.
So let's talk about the how.
Okay.
What are some practical strategies
Right.
for getting better at understanding problems before we even open up our code editor?
Well, the Algo Academy blog outlines some really great strategies. One of the simplest but most effective is to read the problem statement multiple times.
Okay.
And I don't mean just skim it,
Right.
but really absorb every detail.
It's like one of those magic eye pictures.
Oh, I like that.
You know, sometimes you got to look at it a few times
Yeah.
from different angles.
It's all about shifting your perspective and really looking for those subtle nuances that you might have missed on a first read.
Okay, so we've read the problem a few times, highlighted the key points. What's next? How do we really like solidify that understanding?
Yeah. Well, one technique that can be really surprisingly helpful is to restate the problem in your own words,
Okay.
as if you're explaining it to somebody who knows nothing about coding.
Ooh, that's a great tip. I find that explaining things to other people, like even if it's just my rubber duck, really
Yeah.
helps me like think it through, you know?
It's about making sure that you've internalized the problem
Okay.
and can articulate it clearly. And while you're restating it, you want to make sure that you're identifying that key information.
Yeah.
Like, what's the input? What's the desired output? Are there any specific constraints
Okay.
or edge cases to watch out for?
So it's like making a little mental checklist
Yeah,
of all the like crucial elements.
exactly. And once you have that clear understanding, you could start thinking about how to break down the problem
Okay.
into smaller, more manageable chunks.
Okay.
And this is where things like visual aids can be really helpful.
I'm a big fan of visual aids.
Yeah.
You know, whether it's just a simple diagram or a full-blown flowchart,
Mhm.
I find that like really helps me wrap my head around it.
Totally.
Yeah.
It's like creating a roadmap for your code.
Yeah.
And speaking of solutions, before you even commit to one specific approach, it can be really helpful to brainstorm
Okay.
a few different options. This will help you to find the most efficient and elegant solution. And it's a great way to demonstrate your problem-solving skills,
Okay.
especially during technical interviews.
Ah, yes. Technical interviews. Those can be pretty intimidating,
Right.
especially when you're thinking about those like, you know, really coveted roles at like Google and Amazon and Facebook and Apple, you know, the FAM companies.
Yeah, yeah. Those
Great.
interviews are notorious for being really challenging,
Yeah.
but
Yeah.
they're not designed to trip you up
Okay.
or test your ability to memorize obscure algorithms.
Okay.
What they're really looking for is your thought process.
So it's more about like how you approach the problem
Exactly.
than having the right answer memorized.
Yeah, and that's where this whole understand the problem first mindset really shines.
Okay.
When you can clearly articulate your understanding of the problem, explain your reasoning, and walk the interviewer through your approach,
Mm-hmm.
it shows that you have those critical thinking skills that they're looking for.
That takes a lot of the pressure off.
Right.
It's not just about like, you know, memorizing code. It's
Yeah.
about like showing,
It's about problem solving.
yeah, your problem solving abilities.
Absolutely. And remember, those problem solving skills are valuable in any job, not just in tech.
Right.
Whether you're writing a report, planning a project, or even just trying to figure out the best route home during rush hour,
Mm-hmm.
being able to break down a problem and approach it strategically is a huge asset.
Okay, so let's take all this and like put it into practice, you know, with an example.
Okay.
The Algo Academy blog uses the maximum subarray problem.
Yeah,
Can you walk me through that a little bit?
absolutely. So the maximum subarray problem asks us to find a contiguous subarray within a given array
Yeah.
that has the largest sum.
Okay.
So in other words, we're looking for a sequence of numbers right next to each other
Okay.
that add up to the biggest possible value.
Okay, so let's say our array has like a mix of positive and negative numbers.
Right.
We need to find that sweet spot where
Right.
like all those numbers add up to the highest total.
Exactly. You got it.
Okay.
So let's apply those strategies we talked about first. We've carefully read the problem statement.
Mm-hmm.
We've identified the key information.
Okay.
We know the input is an array of integers.
Okay.
The output is the sum of the maximum subarray.
Okay.
And there's a constraint. The numbers have to be contiguous. They can't be just scattered.
Right, so no cherry picking.
No cherry picking. They got to be right next to each other.
Gotcha.
Now, to make sure we really understand this,
Yeah.
how would you explain this problem to someone who's never written a line of code in their life?
Okay, let me see. Imagine you're on a treasure hunt.
Okay.
And you have a map that shows a path with different points along the way.
Okay.
And some points have gold, others have penalties.
Okay.
You can only move forward along the path, and you want to find the section of the path
Okay.
where you can collect the most gold, even if you have to take a few penalties along the way.
Brilliant. I love that.
Okay.
You've captured the essence of the problem perfectly.
Okay.
So how can we break this down into smaller, more manageable steps?
Well, I guess we'd need to consider every possible subarray, right?
Okay.
From a single number to the entire array.
You're on the right track.
Okay.
And for each of those subarrays, we would calculate the sum
Okay.
and keep track of the largest sum we've encountered so far.
Okay, so we're like systematically scanning through,
Yeah.
testing out each one, always keeping track of the one with the biggest total.
Exactly. And this is where those visual aids can be really helpful.
Okay.
So let's say our array is -2, 1, -3, 4, -1, 2, 1, -5, 4.
Okay.
We can visually represent the subarrays and their sums, which can make it a lot easier to see the patterns and identify the potential solutions.
I see. So like we start with -2, then
Right.
-2, 1,
Right.
then -2, 1, -3.
Exactly.
A lot.
Yeah. And as you're going through each subarray,
Okay.
You're keeping track of the largest sum.
Okay.
In this case, the subarray 4, negative 1, 2, 1, has the maximum sum of 6.
Okay.
Now, there are actually several different approaches to solving this problem,
Okay.
each with its own trade-offs in terms of efficiency.
I remember from the Alger Academy blog that there's the brute force approach, which
Right.
seems pretty straightforward. You just check every single possible combination.
Right, check every single one.
But I'm guessing that's not the most efficient way to do it.
You're right, brute force can be quite slow for large arrays.
Yeah. Especially if you have, like, a really long array.
Exactly.
Totally.
There are more optimized approaches like divide and conquer and Kadane's algorithm, which take advantage of some clever techniques
Okay.
to find the solution much faster.
So it's not just about finding a solution.
Right.
It's about finding the best solution.
Exactly, the most efficient solution.
And that comes from understanding the problem,
Yeah.
Deeply enough
Right.
to be able to choose the right
Yeah,
approach.
absolutely. And this makes a lot of sense in those technical interviews that we were talking about.
Yeah.
Right?
Yeah.
Being able to analyze a problem, consider different approaches,
Right.
and weigh their efficiency
Mm-hmm.
shows that you have the skills to tackle real-world challenges.
Yeah. It's like having a toolbox full of tools, and knowing which one is best for the job
Exactly.
makes all the difference.
So let's shift gears for a minute
Okay.
and talk about what can happen when we don't take the time to really understand the problem.
Yeah. I'm sure we've all been there.
Oh, yeah.
You get so excited to just dive into the code that you're like, yeah, I got it. And then like 3 hours later, you're like, oh, shoot.
What did I miss?
Yeah, exactly. I actually remember this one project I was working on.
Oh,
I was so excited to get started. I skimmed the project specs and I was like, yeah, this is going to be easy,
Yeah.
Piece of cake.
oh, no.
And I spent hours writing code. I was feeling so productive,
Yeah.
only to realize I had completely missed a crucial detail in the requirements. I basically had to scrap everything and start over.
Oh, no.
Talk about a blow to the ego
Yeah.
and a huge waste of time.
It's a classic example of the pitfalls of rushing to code.
Right.
You think you're saving time,
Yeah.
but you end up creating way more problems for yourself down the line.
It's like that saying, measure twice, cut once.
Yes.
But in coding, it's like, understand thoroughly, code once.
I love that.
And the Auto Academy blog highlights some other pitfalls to be aware of, like overlooking crucial details.
Yes, just like you experienced.
Right.
Right. Those seemingly small details can have a huge impact on your solution.
Yeah, it's like building a bridge, but you forget to account for the weight of the cars.
Exactly.
It might
Yeah.
look fine at first glance, but it's just going to collapse.
Exactly. And then there's the danger of choosing the wrong algorithm for the job.
Okay.
If you haven't fully grasped the problem's constraints, you might pick an algorithm that's way too inefficient or uses way too much memory.
It's like trying to haul a load of bricks in a tiny sports car.
Exactly.
You need a truck.
You need a truck.
And I imagine rushing to code can also lead to like writing overly complex code,
Oh, absolutely. Yeah.
spaghetti code. That's like a nightmare to debug.
When you're rushing, you're much more likely to take shortcuts and cut corners
Right.
and end up with code that's just a tangled mess.
Okay, so we've established that understanding the problem is crucial.
Yes.
But I could also see how this could lead to like analysis paralysis.
That's a great point.
Sometimes I get so caught up in trying to understand every little detail that I never actually start coding.
Yeah, how do you find that balance?
Right. So how do we find that balance?
That's the key.
Yeah.
Finding that balance is key.
Okay.
One practical tip is to set a time limit for your initial analysis phase.
Okay.
Depending on the complexity of the problem, give yourself 5, 10, maybe 15 minutes
Okay.
to really break it down
Gotcha.
before you jump into coding.
It's like a little mental timer,
Exactly.
Time's up.
Yeah,
Start building.
exactly. And once you have a good grasp of the problem, pseudocode can be a great way to bridge the gap
Okay.
between understanding and implementation.
I love pseudocode.
Yeah,
It helps me map out the logic without getting bogged down in syntax.
exactly. It's like sketching out the structure of your code
Yes.
before you start laying the bricks.
I like that.
And remember, you don't have to solve the entire problem in one go.
Okay.
Break it down into smaller, more manageable chunks
Okay.
and test each one as you go.
That way, if you hit a snag,
Yes,
you can more easily backtrack.
exactly.
It's like building a puzzle. You start with the edges,
Yes.
then you fill in the middle,
Love it.
and eventually you have the whole picture.
Exactly. And don't be afraid to go back and revise your understanding of the problem as you go.
Okay.
Sometimes you don't fully grasp those nuances until you're actually knee-deep in the code.
Right.
Flexibility is key in problem solving.
Which makes me think about the rubber duck debugging technique.
Yes.
Sometimes just like saying it out loud
I know.
can help you see things more clearly.
It's surprisingly effective when you have to articulate your thoughts.
Yeah.
You often spot those flaws in your logic that you might have missed otherwise.
So the key takeaway here is that spending time understanding the problem is an investment
Yes.
in better, more efficient solutions.
Absolutely.
It's not about slowing down, it's about working smarter.
Exactly. It's about laying a strong foundation for your code so you can build something robust and elegant.
So for everyone listening, here's a challenge. Think about one problem you're facing right now, even if it's not code related. How could this approach of really understanding the problem before jumping into solutions help you find a better outcome? We'd love to hear your thoughts.
And remember, whether you're building software, writing a book, or even just trying to figure out what to make for dinner, taking that time to truly understand the problem is the first step to finding the best solution. Keep those minds sharp and happy problem solving.